All right, we're going to get rolling. It's 1 o'clock here on the East Coast. Good afternoon, and welcome to this webcast from Innovation Leader in partnership with Level Education from Northeastern University. I'm Scott Kersner, editor and co-founder of Innovation Leader, and really glad you could join us on this afternoon. As you probably know, Innovation Leader is an information service that focuses on corporate innovation and R&D. We reach more than 25,000 innovation executives at large public companies every week, and we provide research templates, reports, case studies, live events, and forums like this one. We like to say that we're relentlessly focused on meeting the needs of corporate innovation and R&D executives, and you can learn more at innovationleader.com. Level Education, just for some background on them, they were the first university-run boot camp, and they've established themselves as the leader in analytics training in Boston, Seattle, Charlotte, Silicon Valley, and Toronto. They've been recognized as a disruptive innovation in higher ed by the Clayton Christensen Institute and as an exemplar of higher education innovation by the U.S. Department of Education in their National Education Technology Plan. They have programs in IoT, cloud computing, and entrepreneurship, and soon in fintech and cybersecurity. And you can find out more about them at leveledu.com. So let's get to our webcast. And today we are joined by Jim Knapik. He has had a long career in wireless technology and software development, and I'll hand things over to Jim for his presentation. He was the executive responsible for AT&T's American Idol text voting technical operations that we all remember, and has been involved with the deployment of a number of high-speed wireless networks. He was the CEO of Oz Communications, which was acquired by Nokia in 2008, and then CEO of Vantrix Communications until 2014. And right now he leads the cloud computing program for Level Education in Seattle. So Jim, thanks for joining us, and we're really excited to see your presentation today and learn a little bit about automating data flows.
Thanks, Scott. So hi, I'm Jim Knapik, Program Director of Cloud Computing at Northeastern University, Seattle campus. I teach cloud computing and data analytics in Level's full-time and part-time boot camps. As Scott said, Level is a startup within Northeastern University, and we've been delivering training for about 2 years now. Today, I'd like to help you understand how to automate your data flows for data analysis. But first, it makes sense to ensure that we all agree on what that means. So data moves through your business pretty much like a river. There are places where data is collected, and we can call that source. Say, for instance, when a customer buys a product or when they sign up to a new service, you collect their personal information, name, address, email address, etc., payment information, and what they purchase, and then record it to process a transaction. If it's a new customer, you store data about them in something like a customer profile. There's at least 2 ways that we can look at the data that we collect. A certain amount is static, and other data is more dynamic. The data that's stored in the transaction is something that changes very frequently, whereas some data doesn't change very much at all. For instance, your customer's personal details in their profile probably won't change too often, but every time that they purchase something from you or they perform an action, you're going to be recording that as a transaction, and you'll get plenty of those. So for instance, if we look at the customer profile data, you can see how it would be relatively static. Payment information may change as someone's credit card expires, or if they want to use a new card versus the previous card. But on the transaction side, you're going to see that they're making purchases, quite frequently. Maybe they're making returns, and you're going to be recording that in some type of transaction file. So other types of dynamic data or transaction data that you might see are web-click traffic, showing what users are doing on your website, where they're clicking, how long they may be hovering over a given region of a web page. You may be collecting information from a factory floor on the readouts of sensitive instruments or instruments involved in a process where temperature stability is a concern for quality. You may be getting information from something like a gas station where you're looking at what the fuel levels are on a daily basis to determine when the next delivery should be made. You can also get transaction data from vending machines stating their stock levels. You may be getting retail transactions from your individual stores telling you what the sales are for that day, or you might be getting ticket sales per movie title by theaters that are part of your business. Excuse me. A simple data flow might look like this. You collect your transaction from a database or a point of sale system. Then you run a report that produces a flat file. Then you extract or download that data to a staging area. You can operate on that data by filtering it for certain types of transactions or combining it with other data to get a complete view without having to reference other tables or files. And then you load that data into a data warehouse or a repository that hopefully is optimized to read millions of rows relatively quickly when you query it. And you should be able to access that data warehouse with SQL or BI tools like Tableau. So the key is to understanding how automating your data flow will benefit your business is to understand the frequency that you do analysis and also how long it takes to process the data in your analysis, both in terms of the duration. For instance, if you start a report at 5 in the evening and it takes until 9 o'clock the next morning, and also the amount of interaction that a given employee has to have in order to make that process work, as well as the support that's required to keep those analysis systems running. So when you consider the resources involved in your workflow, it's likely that they consist of a couple of different categories. If we break it into two categories, we could look at underlying resources and we could look at active resources in the flow. For example, if you're running all your analysis on your computer with Excel, you have underlying resources of your physical desktop computer, its operating systems such as Windows or Mac OS, and software that you might use to back up your computer, because we all regularly back up our computers, right? So the more apparent and active resources are Microsoft Office, say for instance, if you're running Excel. And so anytime you look to improve how you're doing things, you have to take a look at the cost of the underlying and the active resources to make certain that the cost of resources in your new process delivers more value than what you're attempting to replace. So here's a relatively simple example. Say that your business is a regional movie theater, and a possible data workflow might involve getting insight into the performance in terms of revenue for a given movie, such that you could determine whether you want to cut that movie's run short, or you want to extend it, or look at ticket sales during the time of day in a given week, or just a day itself where ticket sales might be low and you want to create some promotional activity in order to increase the attendance for that, either that movie or that theater during the time of day. I'm sorry, was there a question?
Jim, there was one question so far. If I can throw it in, it's someone who says, we're hearing a lot about Tableau, which you just mentioned. We don't use it yet. Can you talk about some of its strengths? So I don't know if that's too much of a digression here and you want to wait to address that till the end, or you want to touch on that now?
Let me touch on it briefly, and we'll probably pepper in comments about Tableau along the way. if you look at, let's take this slide right now where it says movie ticket sales. The little diagram that says views by day over the last 7 days is something that you might use Tableau to get insight into. Excel is typically the way people visualize data, and I'll touch on that in a second. But what Tableau allows you to do is Tableau allows you to access a wider range of data sources and pull them together in a way that, Tableau is known for, what they call storytelling. So what it allows you to do is pull together your data in a way that you can create slides that are easily distributed to your organization such that the data tells a story. Most of the time when people use Excel, they take a snippet of a chart or put a couple of charts together and put it in a PowerPoint deck. Tableau allows you to access a lot of rows of data, filter that, aggregate it, create a story, and then distribute it to your team. It can be a relatively expensive solution, and I'm going to talk about some alternatives as we march through the slides here.
Okay, that was a great answer. Thanks.
So, as it regards to this analysis of the movie theater data, your purchasing systems may output the ticket sales in a line-by-line file that you get in a CSV or comma-separated values file. And the process of getting that data is similar for most businesses. In this case, sure, we're talking about ticket sales for a theater, but those items that you are collecting from a transactional basis could be anything. Could be the number of cars that go through a car wash, could be the number of ads that you are placing for your business. It could be fast food sales, you name it, you can get it in a CSV format, and it needs to go someplace. So typically we want to perform that analysis, and the way that we're going to do it is we're going to put it into some type of repository. We're going to call that repository a data warehouse. It doesn't necessarily mean that that's an overly sophisticated system. It could be something as simple as a Dropbox folder with data from the most recent year where you're collecting ticket sales, one file per day that then you view in Excel. So this is all about moving from concepts that may be relatively either inefficient or don't scale well to concepts that support a lot of data, high performance processing, and managed services, so you don't have to do this on your own without the benefit of an IT staff. The reason why I say that is, small and medium businesses like this fictional movie theater typically use desktop processing and spreadsheets. And by virtue of the fact that the question was, tell us about Tableau, I'm guessing that there's a fair number of people who use Excel to do their analysis. You might also use Google Sheets. It supports a little bit more of a collaborative model, or Smart Sheets, which allows you to combine different types of data than you might normally do with Excel. They're all good solutions, but one thing they have in common, they don't scale particularly well if there are millions of rows of data to be analyzed. And you're probably in good company if you're using Excel, because there's 8 million small businesses in the U.S. that have IT departments of between 1 and 3 people. So the fact that Excel is so pervasive has to do with the fact that most businesses don't have a big IT staff, And Excel is one of those things that you can acquire on your own, and it's pretty much self-service. So let's look at some of the pros and cons of spreadsheets. One of the things that you get with a spreadsheet is what you see is what you get. Sure, you have to look into every cell to find formula, but typically the formulas are straightforward. They might be a little bit cryptic, but certainly easy to see. Once again, they are self-service. You don't need an IT department or to use them. Newer versions of Excel allow you to import from a wide variety of sources, such as databases in the cloud. You can import or connect to local databases, and you can access data formats such as CSV, JSON, XML. You can easily send a spreadsheet and email to your colleagues. You can post it on a shared drive or Dropbox. And it's relatively inexpensive, especially with Office 365. You can have a monthly plan and be able to operate without a big outlay of capital or without a major recurring expense. Now, on the con side, there are certainly limits to the number of rows that you can process in a spreadsheet. Excel in particular is going to cap you at about 1 million rows per sheet. Certainly you can add additional tabs, but as you add those tabs and you have a lot of lines that you are operating on, it's definitely going to slow things down. Calculations are going to take a lot of time. You can turn off calculations, but most people want to see the immediate effect of changing a formula, sorting a column, or something like that. So it's not overly practical to turn off immediate calculations. The other thing about spreadsheets is they don't have a proper form of version control, meaning that there's no easy way to see what has changed in a cell's formula between one version of a spreadsheet and the next. And that can lead to errors that propagate downstream to other calculations, and no easy way to track back to what the initial problem was. As regards how you use a spreadsheet, typically you're running on your own personal computer, which means that you're limited to the processing power and the memory of that computer. As your organization grows and you're working on more and more rows, you probably don't want to be tied to your personal computer, nor be impacted in terms of what you can do while that processing is occurring. And lastly, the data and the formulas are combined, which makes it convenient to look at them together, but kind of difficult to automate in the spreadsheet itself. So if you're using spreadsheets today, why should you look for a better method? Well, you might consider that a new method may be faster. You can probably save some time and money and likely operate in a more robust fashion. So let's take a quick look at what some cost savings might look like. So say you process your transaction data weekly and it takes you 2 hours. If you reduce that time by half, and let's just say we have a 50-week work year, you just saved 50 hours a year. So different businesses may spend more time or less time doing their analysis, so your mileage may vary in terms of the savings, but it's relatively straightforward to calculate the benefits. And what can you do with that time that you save? Well, you can invest that time in training. You can spend more money on advanced tools, or you could just save that time and the employee cost of that reduced analysis and just improve your bottom line. So you could also increase the frequency with which you do your analysis. For instance, say you're doing weekly analysis just because it takes too long. If you can increase or decrease the amount of time that it takes to perform, so you got it from an hour or 2 hours to 5 minutes, you might do it on a daily basis as opposed to a weekly basis. So what are some of the ways to automate your data flows and at least reduce the time that it takes to process your data or the time that it takes to support the systems that do the data processing. You know, as a teacher of data analytics and cloud computing, I'm constantly exposed to new tools offering some pretty material benefits. But not everyone is in the same situation. They don't have an infinite amount of time to evaluate new tools, go to training, and they might not have a a large budget to spend on tools. So when I try to make recommendations, I look to select what I think is a good set of tools that provides a balance between advanced features, are easy to learn and use, and require little or no management. That's pretty key and a theme of what I try to do. Is I always look to see the solution that requires least management first, and oftentimes that means that tool might not provide the greatest granularity of configuration that I would like, but I always want to ensure that I'm maximizing my time. So first I'm going to use the highest level tool with no management, and then when I run into difficulty, then I'll look to find a tool that might be more flexible, which means that it probably is going to require more training and insight, but I'm only going to go there when I have to. The other thing that I want to do is I want to find tools that will scale with my workload, and I'll increase the amount of processing power that they have when the load is high, and I'll pay for it. But when the load is low, then I'm going to decrease the number of resources that I have working for me, and consequently, I'm also going to reduce my expense during that period as well. So that brings us to a concept that is known as Toolchains, and Toolchains are a series of tools used in a specific order. Here are some tool chains that we're going to talk about today. One of the tool chains that I would recommend if you're currently on Excel and you're looking to move into the cloud and use something that is pay as you go with no upfront cost, that would be the top tool chain of S3 or Simple Storage Service, AWS Athena, and then AWS QuickSight. And then the last two are relatively newcomers. They've been around for a couple of years, and we'll talk about them in terms of best of breed tool chains versus the top three, which are one-stop shop tool chains from AWS, from Google, and from Microsoft Azure. So you might ask why we don't just skip the step of obtaining the transaction data in CSV form and just query the database that has our transactions directly. Well, there's a few reasons why we don't do that, and they primarily have to do with performance. Data analysis should be done by a system that won't have any impact on the customers or current operations. And intensive querying or reporting can have a significant impact on the speed with which your transactional system can process requests. The last thing that you want to have happen is someone is running a report on your transactional system, and as a result, you have a customer standing in line in front of a checkout or cash register trying to buy a ticket, and they're having to wait for that report to complete for 30 seconds or whatever the time period is. So you really want to split the analysis of your data from your operational systems. And the reason is because analysis is best done on systems that are optimized for reads. Typically, analysis is optimized by columns and has few simultaneous users, whereas systems that are optimized for write are what transactional operation systems use, and that's because they have a need for record locking. Typically, they do access by rows, and they usually have many simultaneous users. If you can imagine you know, a regional theater with a number of different ticket counters, you can have a lot of people processing transactions simultaneously. So if we want to move from Excel to a cloud-based system that can operate on CSV files or flat files, we could use the S3 Athena QuickSight tool chain. And AWS Athena is an interactive SQL service, runs on top of AWS's cloud storage, S3, and S3 allows you to upload your data into something called buckets. The buckets pretty much look like folders, and they're hierarchical as well. But because they technically store objects versus files, AWS calls them buckets. S3 is designed to be super robust. If you stored 10,000 objects in S3, you on average would expect to lose about an object once every 10 million years. So that's pretty reliable. Athena is based on a distributed query technology developed by Facebook. Facebook uses it to perform analysis on petabytes of data in seconds. So it's a highly optimized system. And then lastly, AWS QuickSight is a business intelligence or visualization software service, which you can use in the same manner as you would Microsoft Power Pivot or Tableau by dragging and dropping dimensions and measures. It's worth noting that even though you can go a long way with minimal or no IT support in using tool chains like, you know, S3 Athena QuickSight, you really need to be at least somewhat knowledgeable about the basics of SQL or SQL. Just about every tool in some way leverages SQL, and Athena is certainly no different. But what Athena does do that's different than a relational database is Athena removes the overhead of needing a DBA or database administrator, but it still operates the same way that a relational database would with respect to using SQL for queries. So to start this tool chain, first you upload your data into S3. You define the fields that you have in your data file. For instance, you could upload your nightly transactions file in CSV, and you could do that with the AWS console or with the command line. Say we were collecting data for a transaction of an example order. What we would need to do is identify the fields that we would collect. In this case, we're saying, okay, there's a date and time stamp. There's an order number, which we're describing as an integer, which can be between the size of that field can go anywhere between -2 billion and the +2 billion. Customer ID we're describing as a small integer, which can go up to 32,000. The product code has something called a tiny int, which is just using a byte. We're presuming that we have less than 255 product codes, and the same with quantity. We're presuming that in this case, the customer is never ordering more than 255 units. And then we have a price, and we're using this decimal field in Athena, which allows us to specify something called precision and scale. And precision is the number of digits in the total field, and then scale is the number of digits to the right of the decimal point. So you can see on this slide all the types of fields that Athena supports, pretty standard as they relate to a normal database. And you can create new schemas for different types of data. Say, for instance, you need to reference the product name from the product code for easier reporting. You can do this by uploading a product code file and joining it to your Athena query to create a new augmented transaction record that just doesn't record a code, which may be difficult to understand as you're doing analysis, but actually has a description of the product in there as well. So what are the steps you go through? Well, first, you need to create an AWS account if you don't have one already. You upload your data into S3, you create an Athena database and table, and then you define their contents. You run a query, and then you download your results, or you can view them in AWS QuickSight if you're interested in a visualization. So when you log into AWS, you would see a bevy of services. AWS has about 13 categories of services and probably north of 60 individual services. And in this case, you can see I have circled the S3 storage system, which is the place that you're going to go first. When you select the S3 storage system, you are going to see a listing that's similar to a file listing. You create a bucket to put your data into. This is just a sample list of buckets that I have listed. And when you create the bucket, you give it a unique name. One of the interesting things about S3 is S3 names are unique, such that you could actually use them as a URL. So if you had a public file that you wanted to share, you can just put in S3, declare that it's public, and someone can access it via a URL, which is kind of a nice thing in certain circumstances. So after we load our data, then what we want to do is we want to go back to our service menu. We are looking for the analytics category of services. We see Athena, and we can select that. And this is not meant to be a tutorial. This is just meant to show you that it's relatively straightforward to create the data, both the database and the table, to be used in AWS Athena. And I know some people might be, I guess, concerned about the technical nature of trying to sign up for cloud services. And I'm just trying to show you a number of screen captures so you can see that it's not too complicated. If you're using any type of online system today, chances are that with just a little bit of training and insight, you can use this first tool chain that I'm describing. So this is pretty straightforward. You create a database, you give it a name. I'm calling it my new database. I'm creating a table, calling it my new table. And then where it says location of data input, you just describe where your data is located in S3. And then when you go to run a query, you can see in the upper right-hand corner, it says select count from BBB 110, 110. And that's just the name of the table. And on the bottom where it says results, you can see that when I select the count, or I'm asking Athena to give me the count of all the records, it's telling me that there's more than 51,000 rows in all in the table called BBB 110, 110. If I want to not just do a text-based query, but I want to look at my data with a visualization tool, I can go to the QuickSight menu, and it shows me either the different types of data sets that I might be able to access, or on the bottom, the existing data sources where I have sample DB and BBB as databases that I have created that I can access with QuickSight. And this should look pretty similar to charting that you would do in Excel, or charting that you may do in Tableau. On the left-hand side, you can see the fields, channel, customer ID, customer name, customer region, and then the dimensions and on top, and the measures on the bottom, build amount, cost, etc. And then you can create your visualizations from those charts. So you can, both get access to the data via SQL, and two, you can create visualizations that you either would use directly, or you can cut and paste the charts and put them into PowerPoint if that's your objective. So what's the benefit of using this tool chain? Well, you get automated backup of your data. We already talked about the reliability of S3 and how, you know, even amongst 10,000 objects, it would take 10 million years before you would potentially lose one. You get easy input to other cloud services, such as, you know, AWS QuickSight for visualization. You can get something that's pretty close to limitless storage. AWS has one of the largest amounts of data storage out of any of the cloud service providers, and it's only you know, about 2 cents per gigabyte per month for the first 50 terabytes, and then it declines from there. And if you're a fan of Google Cloud or Azure, they have similarly attractive prices for storage. And when you run Athena, unlike when you're on your own computer, Athena would look at all the files in that bucket or folder and run your query in parallel. So you may have heard about Hadoop and Elastic MapReduce. Well, you know, the way that the Athena system works with the Presto technology gives you at least as good, if not better, depending on the data in terms of performance and returning results to your queries quickly. You don't need any IT support to manage a database. So similar to Excel, where you can acquire it yourself, depending on the flexibility of your organization, you can sign up for an AWS account on your own, and you can create a Athena database in a matter of minutes. You need a little bit of insight into how to define your fields with respect to data types. But once you do that, that's all you need to do is continue to upload data to the buckets, and you're off and running. So automating the previous flow requires the use of command line tools or a programming language like Python, and so that takes us into the realm of lightweight software development, or at least system administration, which most small organizations don't have the time to invest in. However, you know, using something like Python does provide a great deal of flexibility and opportunity to fully automate your data pipeline, as opposed to just using resources that may really cost effectively allow you to do large scale data analysis. Otherwise, you'll need to run your queries and your charting manually. But at least, like I said, you can operate on some significantly large data sites or data sets and only have to pay for the queries that you run. And when you're not running a query, the only thing that you're incurring is the cost for that data storage. Now, AWS does have a tool called the data pipeline, which would allow you to automate your data workflow, but at the current time, it only supports Redshift, EMR, DynamoDB, and something called RDS, or Relational Database Services. It doesn't support Athena at this time. And you know, for those who might not know, Redshift is an optimized data warehouse for high performance querying. EMR is something similar to Hadoop. DynamoDB is a NoSQL database where you just have key value stores. And RDS is a collection of popular databases like MySQL, Postgres, etc. It also supports Oracle and SQL Server and AWS's own version of Postgres. So, of the three tool chains listed here, Google Cloud Storage, Google BigQuery, and Google Data Studio operate pretty similarly to the S3 toolchain, and the same can be said of Azure SQL Data Warehouse or Azure Data Lake, with Power BI or Tableau as the visualization tool. So I'm not going to go into those in any more detail. Like I said, they're all pretty similar, and depending on if you have a bias or a preference for one of those providers, I'd urge you to look into those tool chains as your first foray into cloud-based data analysis. The other way to look at things is Bestofbreed. I have two favorite tool chains. This is one of them, where you can use either file upload or Amazon S3 for staging, and then something called Panoply, which is a managed database that is self-optimizing, and also a charting service called Chart.io, which acts similar to AWS QuickSight, and those three together give you a self-optimizing data warehouse with built-in support for over 52 APIs. So if you're importing data, for instance, from Salesforce or from HubSpot, you can easily connect Panoply to one of those sources and use Chart.io to diagram or visualize. And the other one that I have an affinity for is this 5-tran Snowflake Tableau data analysis tool chain. And the beauty of Snowflake is Snowflake, much like Athena, separates compute and storage. The storage is just as cheap as S3. The other benefit of Snowflake is Snowflake has a auto on and auto off type of behavior, such that you set the time for your data warehouse to go into sleep mode, so you're not paying for it when you're not using it. But also has an auto on mechanism, such that when you do access it, it immediately comes on. So it has the benefit of not having to run all the time, like Amazon Redshift, and as a result, your expense should be less. But it also has this automatic scaling capability where you define the base level of resources, and then when the load is going beyond that base level of resources, it can burst up until whatever you define as the maximum number of resources to put in place as your demand on your data warehouse increases. And similar to Panoply, by using this data helper piece of the software called 5-tran, you can get access to 39 APIs, similar to Panoply's ability to access things like Salesforce data, HubSpot data, etc., and also access to 12 different database types. It gives you performance on par with Redshift without the need for cluster management. So for full-on automation, and this is like the next step of involvement with respect to requiring some training and insight, would be 5-tran or S3 as a means of uploading the data, Snowflake for the place that I like to use as a data warehouse. But then I would use either Python or command line scripts and R to visualize the data, and I can swap out either Python graphing or R programming graphing with Tableau as well. So that would be at the more advanced end of a tool chain that would provide you complete automation. So, there's a lot of people who are wary about programming. I just wanted to show how relatively straightforward, if you just develop a basic understanding of Python coding. This is just a couple lines of code that just allows you to access your data warehouse. And as you can see, where it says select star from my table limit 3, it's just an SQL command that you're executing, and then I'm just printing out the data. So it's not, you shouldn't view Python or R as daunting. It requires a little bit of effort, but I think it's, and the reason why is because systems like R and Python, with respect to time to learn, might be more intensive or take more time, but as far as operating costs, they have the lowest operating costs because they're free. When you have systems like Snowflake and Athena that provide a higher level of abstraction and also as a result have lower granularity for you to be able to manipulate things, they're going to be easier to learn, but operating costs over time is going to be more. So closing thoughts. If you look at cloud services, I often like to say, you know, it's like standing on the shoulders of giants. You operate at the highest level of abstraction, and as a result, you're able to benefit by all the things that somebody with great technology insight created, and you can focus on, you know, just your distinctive competency as it relates to your business. It's likely it's going to be faster and cheaper than if you did it yourself. If you have an IT organization that is operating their own databases and doing all their own database administration, they're probably better off relying on a higher level service from the likes of an Amazon or a Google or an Azure. When you look at a third-party solution like a cloud provider, always consider all the costs. As I mentioned, you know, depending on the service that you select, training is either going to be more or less intensive, and you should, you know, ensure that the time and the money that you're spending on the training and the reduced cost of operation really is going to be a improvement over what you have today. And more often than not, that's going to be the case, but you should certainly convince yourself that that's the case. And, you know, different solutions are going to work for different organizations. Some organizations, because they're Microsoft shops, are going to better integrate with the services that you would find in Azure Cloud versus Google Cloud. And so when you're doing data analysis, pretty much when you're doing, you know, anything as relates to business, you should be focused on cycle time reduction, right? So what we want to do is we want to say, how long does it take me to do analysis today? What are the resources that I have to bring to bear in order to do that? And if I reduce it, how much money am I saving? And as a result, if I reinvest that, how does that benefit my organization? You want to start simple and you want to build on success. One of the reasons why I described the first tool chain, the S3, Athena, QuickSight tool chain is because it's the most simple and it's the cheapest. And once you cut your teeth on that and you derive some benefits, then you can look to other tool chains that may be more sophisticated and require more training. But, you know, really focus on the technology that differentiates your business, not the technology that you could create that everyone else has created already. And by using cloud services, you're allowed to focus on those things that make you different and increase your value prop, as opposed to the things that would be in the care and feeding and hygiene category. So with that, I'll open it up for questions.
Okay, Jim, you covered so much ground, so thanks for packing all that in. Anyone who has questions, you can use the chat interface to start off with, and then I can also unmute folks if you want to ask questions the old-fashioned way. But we already have a couple of questions. One is asking, Jim, if you've seen some examples of companies using social media networks to gather and organize data about consumer preferences. And specifically, this person says preferences or opinions about our company and others in our industry. So like, have you seen people doing this kind of you know, data gathering and collation and organization around, you know, what people are saying on social media about my company?
Yes and no. I'm working on actually a project right now where I am collecting review and complaint data and creating a normalized scale of sentiment analysis based on those reviews and complaints, so we can determine, you know, because a lot of times what you'll see is someone will give a net promoter score that is high, and then they'll put in a complaint, right, in the same form. So when you do things like test what customers or users say about your service, you really need to normalize it to make certain that the language that they're using is not extreme as it relates to their experience and all the other reviews or complaints that you might get. So that's probably one of the most complex forms of analysis, and we actually do a bit of machine learning there. But the bottom line is you have to start collecting the data to begin with, right? And so the systems that I showed as regards, in particular, Panoply, because it has the highest number of interfaces, will allow you to do things like collect, you know, Twitter information or, you know, HubSpot information. I mean, where it depends on what your source of information is. But the first thing to do is collect it, and then step two is to analyze it. So yes, a lot of people are doing that analysis. It's one of the most sophisticated forms of analysis that's going on. But first thing you have to do is you have to collect it, and you have to have systems that can process the legions of responses or reviews that are posted for it even to be tractable.
Okay, let's get to the other question that came in through chat. And that is, what is your advice about business people working with the IT department to deploy some of this technology? And I guess maybe the subtext to that question is, you know, IT may not necessarily love all of these cloud services that you've been talking about in this webcast.
You can keep your IT team honest, right? If somebody says it's going to take a year to deploy a service, you know, there have been cases where I've worked with organizations where I couldn't get the access that I wanted. And what I did was I put together, you know, an analysis with cloud-based tools and showed them what was possible. And then all of a sudden I have a bunch of active listeners. So, you know, you have to be a good sport. You have to be a team player, but there's nothing saying that you can't keep people honest by saying, well, what about this tool and that tool, and you know, the promises or the benefits that I've seen from them. So I don't think that everyone should go off if they are in a large organization. You know, one of the things that I think about is even within a large organization, you have small groups that need to get stuff done quickly. And so either you can look at the things that I described as you being a person in a large organization but a small team, or you could view what I talked about as being a startup where you have, you know, 10 people and you have to really move mountains, and the way that you can do it is with cloud-based services. When you're in a large organization, it gets tricky, right? There's politics, but I think that the most constructive thing to do is to develop enough knowledge, and what I try to do here is give a survey of potential services so you could know where to investigate and do a little bit of research, and then, you know, bring it up to your IT team. And you know, if you can speak knowledgeably about the benefits of a service, you're going to have a better chance of influencing them once you know, because they may not have the time to be up on some of the services that may be beneficial. So being informed is always the best way to engage somebody who you're trying to motivate.
All right, let's see if we can get to two last questions here. One is, I think, a simple one, which is folks asking if if we can share your slides with them. And I think the answer to that is probably yes, but let me ask it anyway.
Yeah, that's no problem. I have some resources that I didn't add to the slide, probably half a dozen or more URLs that will, as I, look at different articles, how-tos and whatnot, I do a certain amount of collection and curation of what I think more helpful and succinct information is, and I'd like to add that because I think people will benefit from that.
Great, that would be fantastic. And last question is for someone who says they are in the manufacturing industry, they're still really spreadsheet dependent. What would you recommend as the initial baby steps to getting started? And I assume they mean of getting started with automating data flows.
Yeah, I would look at the S3, Athena, QuickSight, Toolchain, or I would, and it depends on the ability of your organization to spend money. If you are cash strapped, you might look at something like the Toolchain that I just described. If you are an organization that is able to spend money on something like Tableau, you might just start by moving the visualization piece from Excel to Tableau, and then you can decide later on whether you want to put your data into cloud storage like AWS or Google Cloud, etc. So visualization a lot of times is the great motivator for people to move forward. And even though the quote unquote technically logical thing to do would be first focus on building your data warehouse and then your visualization, a lot of times, you need to motivate people, and technically logical isn't the best route. So in that case, by showing them the depth of information that you can get with a better visualization tool may be the motivator to get people to think about a data warehouse and then widespread use of self-service BI tools.
Okay, let's see. We have 1 minute left. Maybe can we squeeze a quick answer into this question? What would be the best tool chain to use that's most compatible with the Linux OS?
AWS. Just about anything you use in AWS is highly Linux-based. If you look at the population of servers in the AWS cloud, Windows is a tiny portion of that, whereas Linux dominates. So I would spend my time in AWS if I was a Linux biased person, which I am.
Great. Well, I want to thank you so much, Jim, for leading this webcast today. As I said before, you really packed a lot in here, and I think people had a lot of questions for you, including one comment that just came in. I'm a happy Northeastern University level data analytics boot camp grad in Boston. So that's kind of an endorsement and someone who's excited that you're willing to share the slides. So thanks everyone for joining us. Thanks especially to Jim for leading this. I want to just mention one thing before you log off, and that's our fall event that we're doing at MIT this October, the Teach-In. It's October 10th to 12th. And our friend Nick Dukoff at Level Education is going to be there to lead a session, along with executives from ESPN and American Express and Royal Caribbean Cruise Lines, Hyatt Hotels. And you can find out more about the Teach-In at innovationleader.com/teach. Thanks again to you, Jim. I really appreciate it. And thanks to everyone for logging in. Have a really fantastic rest of the day, and hopefully you'll join us again on another webcast or conference call soon.